Sushreeya, and today, you guessed what my topic is. Very scientific. So can you guess? Well, what's blowing my hair? Oh yeah, that was so much easier. Well, it's air, certainly. Now, what is air? Well, now, Hindus believe that there's 49 types of this air. But now Greeks believe a so lower number. You are absolutely correct. Number 2, there are 2 types of air, but what are those? Well, one air is air, and the other is ether. Now, air is the lower part of the sky which contains the air. The easiest part that comes to us to breathe, which technically reaches the trees for oxygen. Now, if you can guess ether is actually the cosmos. Cosmos are basically space where the moon, the stars, those are located. Now, for this, that's the upper part of the air where that is. So that is what ether is. Now, let us learn the basic part of air. Basic part is that we're going to do a very small experiment sometimes in the middle. It's very easy. We don't need any supplies. We just need our hand and our breath or our mouth. So let's start. The first one is basically same with the basic experiment with air. Now we can see is that, so what is basically air? The basic things. The basic thing is air is take a long breath. Did you just see I took in a breath? Now, can you guess what I was breathing? This is probably the easiest question. Let's leave it. It's air. Of course it's air. Of course, certainly, right? But now, what do we mean by air? Now, we need the particular definition, right, of what is air. Air is a mixture of a lot of gases. These gases include nitrogen, oxygen, argon, and, the other gases. We call these other gases like the carbon dioxide, helium, hydrogen, neon, xenon, and just other stuff like this, or carbon monoxide. There are other gases that are like this that we say that is in the cycle. Now, speaking of mixture, I'll tell you the percents. Now, we think that oxygen is the most. Nitrogen is actually the most with the 78%. Now, oxygen has become now second place, not too bad, with 21%. Now, here's where 0 point something is. Argon and the other gases, they are very less. Argon is for next place, third. That is 0.9%. Still very small. The least amount, and this is so small that if you want to show this on a picture, you just have to draw a line and color something. Just put a marker or something. 0.1%, or the loser, is other gases. Well, now, we don't usually contain much of the other gases. And specifically, if we're talking about carbon dioxide, you specifically absolutely do not need this at all. Most of all, oxygen and nitrogen, the 2 main gases. If you agree with me that air is invisible, you are absolutely correct. But, like right now, how do you even notice that air is here? Well, number 1 is you feel it. When you blow against your palm, did you just feel your breath, which is technically air? Not only that, anyway, since I'm outside, let's take an example of these trees. These trees are moving because of the wind, flowing air that is pushing it. This is technically the 2 easy ways to recommend air. But when it's really calm, you still know that's air, because air is a particular gas that when there is a force that comes to hit air, it just spreads. Like right now, if I'm outside and I open the door in any specific particular house, the air that is getting forced can go into the room or whatever room I'm opening the door in. That's basically how the area gets. But in a house, there's really not that much of the air unless you're like, get it? Now, we have to talk specifically about solids, liquid, and gases. Now, this is very simple, guys. You should have no problems, absolute problems with solids, liquid, and gases. Why? Because this is very simple. These are known as states of matter, 3 types. There is solids, there's liquids, and gases. since I said first solid, let's talk a little bit about solid. Now, a solid can take a shape, but cannot change its shape really easily or never change its volume. Why can it not change its shape very easily? Let's say I'm holding glass right now. Just pretend it's glass, okay? A big glass of rectangular plate. Now, if I drop it, pretend this is wood, and I drop it. It broke into these little pieces. Now, something that's very fragile solid, like glass or wood, those can easily break because when it falls and hits a surface, it breaks into tiny pieces. Now, some don't. Like, this is a chair, right? I can carry it, it's actually light, but if I just drop it, it's really not going to break that much because of the plastic and the material it's made of. So it's really hard for a lot of solids to change their shape. Like, the ones easily would probably be through examples of maybe ice, glass, but some don't, like plastic, right? Now, since I said second of liquid can change its shape very easily. Now, let's say I have a tank right here, a big tank, okay? Now, this tank is full of water, okay? No fish, nothing, it's just full of water. If I dump it and I refill water, well, the only thing is that it easily takes shape because a liquid, let's take an example. Let's say it's breakfast time, you're drinking your milk or water, whatever. When you're pouring it in the glass, it takes the shape of the glass or the container, right? Or the little jar or whatever. But why? Because it's so fragile and it can easily move around, right? Now, gas. It's easily also allowed to change its volume. Now, specifically, gas can always change its shape because gas, the easiest thing to think of is just our air we breathe, right? And it's moving everywhere that if it hits something, it can easily just take a shape. Like, maybe if there's a jar that's upside down, maybe there's a little hole or something that we can't see because in all materials there is a special hole that we did not notice that scientists have figured out that we don't see, but the air goes in there, so sometimes we don't really notice. Like in this material of the chair I'm sitting in, you see these little holes? The air can just go through. But if I put water, unless it's like this type where I'm sitting on it, it's really hard for the water to go through. So gas can go anywhere very easily, which means gas must be the fragilest. Then is liquid, then is solid. Now, when we're talking about solid, we're still on the topic. Not all solids are very still. Like grass. Grass is definitely a solid because it stays still unless you really bend it. So that's kind of unexpected that maybe scientists will discover later of a solid, because solids have to be very still, like my bone. That's a very good example. Now let's talk a little bit more about air, okay? Some very interesting topics about air. Did you know that if the air flows and it hits each other, it doesn't really do anything? Do you know why? The only reason is because when the air hits something swiftly, it's kind of swiftly, if you don't know, it's like a medium-ish slowest. And if it hits something, it just allows it to move. Now there are even heavy winds, right? The heavy winds can break something. Now there's even light winds. Why do we say there's light winds? I mean, we have to breathe in light air, okay? So let's take an example of what I'm breathing. That's light air, right? Also known as the oxygen we're breathing. Now after it's translated in my lungs, I'm going to exhale it out of my body. Out of my mouth. This is what we say is the carbon dioxide. These two are the specific air our body uses to translate. Now, if you don't know what exhale means, because I said we exhale means you breathe it out. This is what I wanted. So friends, this is what I wanted to discuss with you guys about this scientific topic of our air. Now, air is very important, so remember we use it properly too. Okay, guys? So have a good day. See you soon. And if you have questions, make sure you put in the comments because, guys, please understand I don't want you to have any doubts. And same about other speeches. If you have questions, please also put them in the comments. I don't want you to have any doubts, okay? Have a good day. See you soon. Bye.